In this video, we look at some operations with matrices. So in this first example, we are going to solve the matrix equation AX equals 0. So we can start by rewriting this as a system of linear equations. Notice X is a vector, so if you want to write it bold or with a vector arrow on top, that's just fine. And the same with 0, we can think about that as a vector or a 3x1 matrix. So our system of equations here, if we do our multiplication through, from the first row of matrix A multiplied by column vector X, we have 2x1 minus 1x2, or just minus x2, and then minus x3 equals 0. And our second row of matrix A gives us 1x1, or just x1, minus 2x2 plus 2x3 equals 0 here. All right, so we can construct an augmented matrix. So we could take the coefficient matrix, matrix A, and augment it with our solution matrix, the 0 column vector there. So that'd be 2, -1, -1, 0 in the first row, and 1, -2, 2, 0 in the second row. So we want to use Gauss-Jordan elimination to get this into reduced row echelon form. So I'm going to head over to Simpy and let Symbolic Python do that for me. So I'm going to enter my augmented matrix. I'll call it A equals matrix in parentheses, and in brackets I put our rows here. And then our second row is 1, -2, 2, and 0. Close it off with double brackets and parentheses, and then we can verify it and just check. Matrix A is as we think it should be. And then we can do A dot ref parentheses, and then we just want the first result from our output. And so here we get our reduced row echelon form. And so we're going to go back to our worksheet here and put that down here. So through reduced row echelon form, which we can call RREF for short, we get this resultant matrix 1, 0, 0, 1, -4/3, -5/3, and 0 and 0. All right, so let's think about what that means in terms of the solution. So I'll recopy our matrix here. And so in terms of thinking about these variables associated with the columns as x1, x2, and x3, and these values as our coefficient that goes with the x1, x2, and x3. The first row gives us x1 plus 0, x2 minus 4/3, x3 equals 0 here. Or more simply, x1 minus 4/3 x3 equals 0. Or you could say x1 equals 4/3 x3. Now, when we write solutions, we want to write these in terms of a free variable if we have that. So in this case, we have 2 rows and 3 variables. So we do have a free variable, and we can say x3 is that free variable. We could go ahead and call x3 t, but we'd have to deal with this fraction. And so in order to make lives a little bit easier and eliminate dealing with the fractions, we're going to use that denominator 3 that shows up in both fractions here, and say x3 equals 3t. And if I'm solving for x1, x1 is going to be 4/3 times 3t, and our 3 nicely cancel there, so x1 is 4t. And then we can also solve for x2. So we know over here from the second row that 0 x1 plus 1 x2, or just x2, minus 5/3 x3 equals 0. But now we can replace x3 with 3t. So we can say, okay, x2 is going to equal 5/3 x3, or x2 equals 5/3 times 3t, or x2 equals 5t. So in terms of the free variable, we would say that the solution to the system is going to be x1 equals 4t, x2 equals 5t, and x3 equals 3t. So we see the dependence between the variables depending on our choice of t, and t can be any real number. Okay, let's look at another example working with matrix multiplication. So we want to write the column matrix B here as a linear combination of the columns of A. I'm going to start by constructing the augmented matrix here, and then go ahead and do reduced row echelon form. So our augmented matrix is going to be 1, 1, 2, 1, 0, negative 1, 5, negative 1, negative 1, and then augmenting with matrix B, 3, 1, 0 here. All right, so let's get the reduced row echelon form using technology. So I'm going to head over to Cynthia and enter this matrix. And I'll call it matrix A. I'm not very original, so I can use A for the matrix variables. And so we'll put in here our first row, 1, 1, negative 5, 3. Our second row is 1, 0, negative 1, 1. And our third row is 2, negative 1, negative 1, and 0. And just double check our matrix A. It looks like that's a match for the augmented matrix that we wrote by hand. And so we're in business. So now I want to do reduced row echelon form. So since I typed that earlier with a different matrix that I also called A, I just use the up arrow to bring back my reduced row echelon code to go work it on my new matrix A. And here is our reduced matrix form. So we will write this over here. And this will be the values that we'll work with. So the call reduced row echelon form gives us this nice triangular form with the solutions. And in every row, it's just got the 1 and then zeros in all of their positions, as well as in every column, you've just got 1s and zeros in all of their positions. This is a good looking solution here for us. So now we want to rewrite matrix B in terms of the original columns of A. So the values in our solutions, the reduced row echelon form matrix, are going to be the coefficients that we multiply the columns of A by. So we can say now, okay, B equals 1 times column 1, 1, 2 from matrix A plus 2 times column 1, 0, negative 1 from matrix A. And you could pull them from matrix A over here. I'm pulling them from the augmented matrix. either way for the same columns. And then 0 from 0 multiplied by column 3 for matrix A, 5, -1, -1. And then if we do our calculations here, this is 1 times 1 plus 2, and then plus 0 in the last column. So this gives us 3 for the first value of column B or matrix B. B is a 3 by 1 matrix, so sometimes we just think of it as a single column. So that's a match right here. And then our next calculation is 1 times 1 plus zeros. And so that's the 1. That's a match right here for what we have. And then we get 1 times 2 is 2. And then we get a minus 2 there, which gives us 0, which is a match here. So we have checked our work that we have successfully rewritten matrix column B as a linear combination of the columns of A.